So next up for 4.3 and 4, we're going to talk about logarithmic functions. So when we are dealing with logs, logs are the inverses of exponentials. So every log and every exponential can be written as each other. If we have, why did I put a b there? If we have log with base b of y equals x, that is the same as saying b to the x equals y. These are used interchangeably. Okay. The other thing that a log is asking you is, to what power do I take this number to get this? So to what power do I take a 3 to get 1 over 81? 3 to what is 1 over 81? Well, we know that 3 to the, what is it? So it's 3, 9, 27, 81. So 3 to the 4th is 81. But since this is 1 over 81, that would be 3 to the negative 4 is 1 over 81. 5 to what power is 1? Well, 5 to the 0 power is 1. In fact, anything to the 0 power is 1. If you have a 1 right here, you should have a 0 over here. Four to what power is the square root of 64? So I'm going to rewrite that 64, because that is 64 to the 1/2. The square root is the same as to the 1/2, right? But I can also rewrite 64 so that it is base 4, because 64 is 4 to the 3rds. And then remember, when we take a power to a power, we multiply. So then that would be 4 to the 3/2. Which makes sense, because 4 to the 3rd is 64, and then the 1/2 from the square root. Now, since logs and exponentials are inverses of one another, the 8 here and the log base 8 are inverses, so we would just be left with the 3. Okay. Now, e is a special base for a log. When we have log with base e, we don't write it that way. We write it as the ln. So the ln is the natural log, and that is log with base e. So then the ln and e are inverses, which means that this would just be negative 11. This would just be 5. This would just be the square root of 3. And then here, remember, we just talked about negative exponents, how they mean the reciprocal. So I'm going to change this to the ln of e to the negative 5, because the negative means to take the reciprocal. So then this would just be negative 5. Now, we could have done every single one of those problems in our calculator. All of them. You didn't have to do any of them by hand. If you have a TI-83, then you need to use the change of base formula. So if you have a TI-83, in order to put this in your calculator, you would have to use this log button right here. It would help if you could actually see what I was pointing at. The one next to the 7. And you would do the log of 1 over 81 divided by the log of 3. Now, if you have a TI-84, you can press the math button, and you're going to scroll down a little bit, but it's there. See how this says log base? So that would be log base 3 of 1 over 81. They're the same thing. So if you have a TI-84, you could do it either way. If you have a TI-83, you have to do it the top way. And then your E and your ln button are right below log. So like, if you were really perplexed about this one, you could have said, okay, what is the ln of 1 over e to the 5th. Always an option. Okay. So now I just mentioned how we convert these to you. So here, when I convert this, it would be log with base 4 of a equals y. This would be log with base e, but we don't write log with base e, we write ln of c equals a. So then this one would be c to the b minus 1 equals p minus 6. I feel like that one's unnecessarily difficult, but okay. All right. So 3 steps to find the inverse. We talked about inverse functions a while ago, but let's remind ourselves the 3 steps to find an inverse are change f of x to y, swap x and y, and then solve for y. So I'm going to make this y equals 5 to the x plus 2 minus 3. And then I'm going to solve, then I'm going to change it x equals 5 to the y plus 2. Then I'm going to solve for y. So the first thing I'm going to do to solve for y is get this 3 over. Now I have x plus 3 equals 5 to the y plus 2. Once your base has nothing in front of it and nothing behind it, then you're going to turn this into a log. So as a log, this would be log with base 5 of x plus 3 equals y minus 2, y plus 2. Log with base 5 of x plus 3 equals y plus 2. Subtract the 2. So we have log with base 5 of x plus 3 with a minus 2 on the outside. And that's my inverse. So, a couple of notes about logs. First of all, if we're thinking about our basic log function, its domain is the positives. You can't put 0 or a negative into a log. Its range is all real numbers. It has an intercept at 1, 0. Because again, if I put a 1 here, it doesn't matter what the base is. Any base to the 0 power is 1. So if there's a 1 here, there should be a 0 here. If there's a 0 here, there should be a 1 here. And then it's got an asymptote, a vertical asymptote at x equals 0. And now, if we went back and looked at our exponential graph, right? I'm going to leave that right there. Maybe I'm not, because I want to try to get everything. The exponential graph, when I was talking about y equals a times b to the x, this one had a domain of all real numbers, a range of the positives, an intercept at 0, 1, and an asymptote at y equals 0. So you see how everything flipped around? That's because these two are inverses. Okay, so here, this is a basic log function that has been shifted to the left 9 and up 10. Well, my domain is normally 0 to infinity, but that gets shifted left 9. So if I take 0 to infinity and I shift it to the left 9, I'm going to end up with negative 9 to infinity. My range is all real numbers. The range for every log is always all real numbers. And logs always have a vertical asymptote at whatever this number is inside. Well, but we have to flip the sign because it got shifted left 9. So remember how I told you that the end behavior here was always based on this number on the outside? That's my horizontal asymptote for an exponential. On a log, again, since they're inverses, it's the number on the inside and it's a vertical asymptote. So their properties mirror one another since they're inverses. Questions about any of that?